Hello everyone and welcome to my TR-808 restoration video. I've done a little bit of preparation beforehand. I've ordered quite a few of the parts that I'll need. Most of them have come in. I'm waiting on a couple of things. So the actuator board and the switch caps I just got off eBay. It's an old technology transplant board, but you can get them from Cintor now as well, with the caps and the switches already installed. The problem with this one that I've got from Technology Transplant is that the length from the first step switch to the 16th step switch is slightly shorter than the original, so it doesn't quite fit as well in the 808. Which I'll hopefully get to show you later. So what I'm going to do is not actually use that one. I'm going to use the original and just replace the actuators and switches. So I've got some here that I bought from Cintor. These two have the actuator and the switch integrated together, and there's a couple here that are just the actuators themselves. They all come with new LEDs, but I won't be using these LEDs because they will be brighter than the originals. I'd like to keep all the LEDs the same brightness if possible. And the next thing, the start-stop caps. So I've tried to get one 3D printed. This one is from Shapeways, but it's not entirely the right shape. It's quite bent actually. You can see from underneath. That's just not right. So this one was a bit of an epic failure, to say the least. Unfortunately there's nothing you can do about the colour in the original, so I've decided to just cheat and buy a CSQ 100 which has the same switch caps, and most of the time those old Roland sequencers were just shoved in people's cupboards and not exposed to UV. So their switch caps are a lot clearer than the 808 switch caps. Some of the screws already in. I spent a long time trying to find the same screws because it always annoys me. The 808 screws in particular are quite often really rusty. You can't see properly. The light's not very good, but they do rust quite badly and they look quite bad. So I'm trying to find the exact replacement screws, or at least as close as I can, with the same profiles and same threads. So that's one mission. I've got pots here, lots of new pots. These are from Cintor. The intention was to replace all the pots that were cracked and broken. So you can see here, someone's already put a sticker on the top, so that one's the original inserts missing. But most of them, hang on, need some more light. Here we go. So most of them you can see are quite cracked. See that one especially, it's quite cracked. A lot of them are cracked, a bit horrible. Some of them are alright. So the intention was to replace just the pots that were cracked and broken and a bit yucky, but it turns out the ones from Cintor's don't have the same insert. They just have a sticker on the top and they're not even put in properly. So you can see that sticker there, that's not even lining up with the notch. And I think someone's tried to push this sticker in with a sharp implement and even marked it. So that's not really good enough for a restoration. You can see the original inserts were made of plastic. They were just punched out of a solid piece of plastic. And they were inserted before the pot was actually finished being made. So what they would do is put the insert in the top of the pot like that, and then they'd have a tool that comes down and crimps and melts the top over that insert. So if you have a look on some of them, you can see that the insert is actually molded in to the top of the plastic. So once they fall out, you can't get them back in because the plastic around the top of the insert isn't holding it in anymore. So you can see once they crack away, they just fall out. So there's really no way to repair them. And unfortunately, the replacement pots don't have anything like the original inserts. They're just stickers, which is a real bummer. But anyway, we'll see what we can do. I was thinking of maybe filing or sanding down the inserts to make them fit in the Syntor ones and gluing them in, but I don't think that's going to work, so I haven't quite got a solution for that yet, so we'll see what happens. And I bought some of the insert stickers off eBay as well, just to see if they were better than the Syntor versions. Colour's slightly different, but other than that they're kind of sort of the same, so I don't know how well that's going to turn out. I'd rather the original pots. Alright, so that's it for the parts that I have. The only other thing I'm going to need a transformer for it. This one is the Japanese model, so it's 110 volts. I'm going to have to change that to 240. Okay, so I'm going to start by taking the side panels off. But normally you would probably just split the top and the bottom if you needed to do something simple. To do that, there's just the 2 screws at the top on each side. There's 3 at the front and there's 3 at the rear. Once you've undone those, it just splits apart. But I'm going to start by taking the side panels off. So there's actually 4 underneath on each side to get the side panels off. The ones at the bottom are easy to forget. Okay, so the 4 screws along the bottom have been taken out. The 2 on the top, at the back, so we can just pull the side panels out. So the next thing I'm going to do is take off the knobs, because it'll make it easier later on when I get the circuit board off the front panel. So they all just pull off. They're not held on by any grub screws or anything. There is a nut here underneath this pot that you'll need to remove before you take the circuit board off the front panel. But apart from that, there's just the screws on the top surface. But before I do that, I'm going to just split the top and the bottom. Okay, so once those screws are undone, the 3 at the front and the 3 at the back, you'll be able to separate the top from the bottom. Just be careful when you're separating it that it doesn't actually disconnect. The mains wires are permanently wired between the 2, so you'll need to keep them close together when you separate them out. So what I might do is just take out the circuit board, because that's the thing we'll be doing the most work on. So you just undo all the plugs. So after you've undone all the plugs, it's just a matter of unscrewing the circuit board from the front panel. So it's the remaining screws that are left on the top here that you undo. I usually leave the middle screw in as the last screw, so I can put my hand around the back and hold the circuit board when it comes out. And that's it, it's out. So the first thing I'm going to do is take the step switch board out, remove the switch caps and replace the actuators and the switches that are not so good. It's not too difficult to get out. The screws are pretty obvious. So just be careful when you take the board out that you don't break the ribbon cable. It just pulls out of the connector. So the first thing I usually do is take the switch caps off. Now I have spent many hours trying to get them out from the front and from the side, but by far the easiest way is to get the smallest flat screwdriver that you have and put it under the side where the LED is, because you can get onto the rear feet of the attachment and then pry it apart really easily. So the part that you want to put your screwdriver on is just this bit here. There's a thicker bit just in front of where the hinge is. The hinge is here, and just in front of that there's a thicker part. If you put your screwdriver on that, you can pry off the top cap really well. If you do it from the front, it's just really difficult, doesn't seem to come off, and there's nowhere to grab it from the side. So the best way is just from the rear here. So you just go along and do that from every switch cap. You can even just put your screwdriver in and rotate it a little bit, that's usually enough. Okay, so there's all the switch caps off. So the next thing to do is remove the plastic strip that's in between the top of the actuator and the button. This is only on the originals, but you can't get the actuators off until you remove it. It's just glued on each end. So once you remove it, just a bit of glue from each of the ends, it just comes off, it's pretty easy. And then we just unsolder the actuators, which are the 4 large pads and the 2 small pads at the front, which is the LED. So you need to do all 6 to get it off. So as I said before, one of the switch caps looked a bit wobbly and I thought the actuator was a bit busted. So this is the one. You can see that the hinge on this side is broken off and the other side looks like someone's tried to glue it back on even. So maybe it's entirely snapped off previously and the last person's tried to glue it back on and there's only one part of the glue still hanging on. So if any of them are busted, they'll wobble quite a bit. So that one obviously needs to be replaced. Most of the other ones look okay though. They're not too bad. So just to reiterate how to get the switch caps off, you want to put your screwdriver just over this part here. So you don't want to put any pressure on the hinge. So you want to force this part down and twist the screwdriver so that the cap comes off like that. So you don't want to lift this in any way from underneath, you want to be on top of that. And then just rotate the screwdriver to get it off. Alright, so what I might do now is actually remove all of them because this board's pretty dirty, and I'll replace the diodes as well. So I might just remove everything from the board and give it a bit of a clean and then put all the new switches and actuators back on. Okay, so to get the actuator off, you just use a screwdriver in from underneath and just heat up the 4 large pads first. Then when you can feel it starting to come off, you can start working on the LED. So just make sure you use desoldering braid or a solder sucker or something like that to get rid of the excess solder on the pads, because you don't want to push through from the other side when you're putting the actuator back in if there's solder still on the pad, because you'll push the track off. So you must have a hole going right through before you put the new actuators in. Then just push the new actuators into the board where the holes are. I've removed the LEDs from the new actuators, and that's because I'm either going to use the old ones to make sure the brightness is the same, or I'm going to use some new low brightness LEDs on all 16 just to make sure that they're even. So I've decided to use some new low brightness LEDs because they were just a little bit redder and a little bit less bright than the Centaur ones. Not quite as good as the original, but they're not bad. And I've got enough of them. They're fairly cheap. I think they're like $5 for 100. So I've started putting them in. It's not that difficult to bend them the right way. If you just get a ruler that has centimeters on it and you bend the legs so that they're a centimeter apart, so about 0.5 millimeters on each side, put the bend. So you can use a ruler to measure it as you go. And if you make some mistakes, just throw them out because they're pretty cheap. So it's worked out pretty well. So I've just started putting them in. I still have to finish soldering it up, but it looks pretty good. So I always use a lead solder for the older instruments like 808s and Moogs and things, because you have to be careful that the tracks don't heat up too much and come off. We're always battling with trying to make sure that the tracks stay in place on these older circuit boards, so using a lower temperature solder is generally a much better idea than the new lead-free stuff. So all the step switches are on the board now. But before I put them in the 808, I thought I'd show you how the technology transplant board fits. So that's this one. You'll recognize it because they have the really white switch caps, and the original switch caps are like a more creamy color. So the original switch caps suit this screen print here. You can tell the technology transplant ones are much whiter, so you can always tell an 808 that's had it replaced because you just look whether the switch caps match the screen print or do they match the top of the pots. If they match the top of the pots, it's the technology transplant one. So if you have a look at step 16, you can see how it's right next to the left hand side of the cutout, and there's lots of gap here on the right hand side. Now when I first put this board in, the switch wouldn't return. It would get stuck on the side. So I couldn't actually use step 16. 15 and 14 were scraping, but they were fine. But 16 wouldn't come back up again. So what I've had to do to get it to work is with the screws that the board attaches to the main board, I've had to loosen them and push the whole board to the right hand side as far as I can, then tighten them. And then I've had to tip the whole 808 on its side, loosen all the screws on the top panel and let the main board slide to the right hand side, and then tighten the screws. And now step 16 actually returns. So now it's fine. But well, without doing that, it was pretty bad. So yeah, it's not quite the right size, and it's not like that the whole way along either. If you look at step 1, it's almost slightly to the other way. It's almost closer to the right hand side of the cutout. Just not spaced like the original. So we start at approximately the right place, but by the time we get to step 16, it's scraping along side of the panel. So I'm going to use the original, and I'll put that in now and we'll compare the two. Before I do that, I'm going to clean them up a little bit, just with some soapy water and a toothbrush. And I'm going to try and recover the colour a little bit, because it's hard to see, but the bottom has the natural colour and the top's a little bit faded because of the UV. Hopefully all the colours should brighten up a little bit once I put them in some hydrogen peroxide and then put them in the sun. So here they are in the hydrogen peroxide. I'm just using a glass. I'll come out every hour or two and mix it around, make sure they're evenly exposed to the sun. Okay, so the original step switches are back in the 808 now. They have brightened up quite a bit. I only left them in the sun for a couple of hours, but it was enough. You can see they're actually slightly whiter than the panel print now. But not excessively so. You can see the technology transparent ones are still just like ultra white, like far too white. So it's actually not bad. It's turned out really well. And you can see step 16 needs no adjustment. It's a miracle. It just works. So the spacing of the original board is perfect, as you'd expect. So it's time to move on to the next bit. The start, stop and tap switches. These things are my pet hate. It's so difficult to get them to look like what they did when they were new. They're quite often really dirty and faded, and the piece of paper underneath with the writing on it is nowhere near the original colour. So we've got a few problems. One is the fact that it's just scratched and dirty and horrible. There's a few things you can do. I tried to get it 3D printed, it didn't work. You can also make your own mould and use your own like plastic cast, and that seems to work quite well. There's a few people that have done that. But I decided to cheat. I'll show you in a second. But one of the things we've got to get right is the colour of the actual writing and the piece of paper underneath. So it wasn't white. You will see a whole lot of 808s around now for sale where these switches look white, and that wasn't the original colour. The original colour is more like this orange with black writing. In fact, it looks exactly like this. This is a CSQ100, yes, that's right. Roland made a product specifically for 808 parts. So these things were stored in people's cupboards for many, many years because no one really used them, and consequently they're all in awesome condition. And the start, stop and tap switches, although they're not called that, are perfect. Look how shiny they are. Like they're shiny. That's amazing. And that's the original background color as well. So I'll get pretty close using this orange card. I just have to print start and stop with the black line in the middle. But look how clean that is. That's amazing. And look, I get these really shiny screws too. They're exactly like the 808 screws. So I get a full set of new shiny screws and start, stop and tap switch covers. And the sides are the same. So that's brilliant. I can't wait to pull it apart. Okay, so next are the pots. I've thought of an okay solution for the stickers on the top. So there are quite a few that are not put on properly or they're marked in some way. I found that if I used the stickers that I bought off eBay, they did go on a lot flatter and they seem to stick a bit better. So I'm going to use those stickers that I bought, so these ones. So just seem to go on a little bit better than the ones that were on there, and also they're not as reflective so they look less like stickers. So that's probably the best solution, and they do look okay. I have another problem though, and that's the shafts on these pots. When you turn them, there's quite a lot of friction, so it turns quite slowly. It's significantly harder to turn compared to the original pots. And one thing I really like about the original 808 pots is that the shafts have almost no friction, so you can just flick them around from one extreme to the other as if to like mute and unmute the track. So yeah, the really great thing about it is that you could just flick them and you'd get the whole travel just by flicking the pot. So you could mute and unmute. And you can't do that with the new pots because they're just too hard to turn. You just can't do that as fast. So what I'm going to do is replace the grease inside them. So here's the original pot. This is an original one. And this is one of the replacement pots. To get them apart, if you have a look at one of these pots, you can see the 4 tabs, one at each corner. So you just lift those tabs up. It's just with a screwdriver. So you've just got this bracket that comes off first, and that's what attaches the pot to the circuit board. So the 3 main electrical connections are here, but this is the one that provides the strength. So remove that first, and then you've got the carbon track. And then we've got the shaft and the cover. So it's this grease that's in here. So we just push the shaft out. So it's the grease that's in the bottom of this cover and around the shaft. Just by getting rid of that grease, it should be enough. If not, I can try a lighter grease, like a lithium grease or something like that. But it should be enough to just wipe it off. And just remember to do the inside of the pot as well, because it'll still have a lot of grease in there. And then just put the two back together. Give it a test. That's much better. That's really good actually. That's awesome. Excellent. So then to reassemble, you'll notice when you put the pot together there's a gap under one side. So you want that gap to be where the electrical connections are, where the legs are, around the other way. That's incorrect. That would short out the pins. So it's the other way, where the gap is. And then you just put the bottom piece on and bend the tabs back over. So you might have to start with some pliers. The first one or two are quite hard to get in. And there it is, the finished one, so that I've bent the tabs back around the bottom. And now it flicks quite fast. Excellent. Exactly how it should do. So now all I have to do is get the old pots out of the 808 and solder these ones in. So the first thing I do when removing the pots is add some solder to the joint, because the old solder quite often isn't very good. And you don't want to take the solder away because it removes your ability to put heat in the joint. Having a good amount of solder allows the joint to stay hotter because you've got more thermal mass there, and you want the joint to stay hot when you move your soldering iron away to the next joint. You want the one that you just came from to stay as hot as possible for as long as possible. The more thermal mass you've got there, the hotter the joint stays, and the easier it is to remove the pot. Okay, so that's nearly done. Alright, that's it. There it is. Don't forget to remove all the solder from the pads. If you can't get all the solder off by approaching it from this side, then turn the board over and do it on the other side too. And before I put the new pots in, I thought I'd give the existing ones a bit of a clean. So I just put some tissue paper around the base of the pot to try and not get water on the bottom, and then give it a bit of a brush. So look how much difference cleaning the pots makes. There's the clean ones, and they're the original colour. The original dirty ones. It almost makes the insert look bigger compared to the dirty ones. That's amazing. So much difference. So I've put the volume pots back in the circuit board, but I haven't soldered them in yet, and I've put the front panel back on the board and put a couple of the screws in just to line it up, because I just want to see how the pots line up with the holes before I solder them in, because once I solder them, it's very difficult to move the pot or change its position. So a couple of them are a little bit out, so I'll make sure they're in the right position before I solder them. Okay, so I've finished soldering in all the pots. So that part's complete now. So it's back together. Looks heaps better than before. Okay, so in summary, I've replaced the level pots. They were from Centaur. They're the ones with the stickers inside. And then I removed the grease so that they move a lot easier like the originals. The other pots were okay. I didn't need to replace them. I've just cleaned them up with a toothbrush and some water. And these switches here, they were quite stuck, and I've just sprayed some isopropanol in and moved them around a bit. All the other pots I've just cleaned with a toothbrush. The screws have been replaced. They were from the CSQ 100 in the end. And the step switches, I've replaced all the step switches and all the LEDs with some matching brightness, really low level brightness LEDs. And the start-stop caps, I put new caps on them, but I didn't end up replacing the that orange card underneath, which should be more orange. It should be more like a bit darker than this, probably even as dark as the writing. So that's still to be done. I had trouble with them because I couldn't get the printout with the same font. So they've remained the same for now. But apart from that, it's gone really well. So next is calibration. There's not much, if anything, I'm going to change with the circuit besides just replacing the power supply caps, the transformer, and maybe a few caps on the main circuit board which filter the power supply, but none of the original sound circuits I'm going to change with this one. So I'm looking forward to doing that, which will be in the next video. So thanks for watching, and I'll hopefully see you again soon.